Welcome to This Explainer. Okay, today we're doing something a little different. We are fundamentally rethinking long-term product health and, engineering velocity. If you've ever been part of a team building software, you know the drill. Keeping your product stable while scaling fast is absolutely one of the hardest balancing acts in the business. So we're going to look at the systems, the processes, and the culture that actually support long-term product health. And we're going to do it by tackling one of the most misunderstood practices in engineering, the code review.
Let's just subvert expectations right out of the gate here. Good code review on a long-running product? It is not about catching bugs. I know, it sounds crazy, right? But protecting your product long-term has entirely different goals than simply hunting for typos or missing semicolons. If you think the ultimate goal of a code review is just catching a bug before it hits production, you are really missing the bigger picture. It's actually about protecting architectural decisions that were made years ago, transferring knowledge across your teams, and preventing the code base from quietly decaying under constant feature pressure.
So here's exactly how we're going to unpack this whole shift today. 1. The invisible code base weight. 2. Why current reviews fail. 3. The hidden breaking change. 4. 4 steps to better reviews. 5. Redundancy over correctness. And finally 6. Bottom line for leaders.
All right, let's jump right into section 1, the invisible code base weight.
So what is this invisible weight? Well, it's a serious architectural threat. When a product has been around for a few years, the code base gets bogged down. It gets heavy with legacy decisions and deprecated patterns. And honestly, the scariest part? All that tribal knowledge is usually just held in the heads of a couple of engineers. If they leave next quarter, poof, that context walks right out the door with them. Weak review processes don't just let bugs slip through, they silently erode the structural integrity of your entire system, literally one merged pull request at a time. Fixing this isn't about buying fancy new tools. It's about fixing the practices that are silently draining your engineering velocity.
Moving on to section 2, why current reviews fail.
There is a massive difference between just checking a box and genuinely evaluating a change. Think about the common mistakes we've all seen, or even made. Reviewing just to nitpick code style, or, let's be honest, approving pull requests just to get them out of your queue so you can get back to work. Or maybe it's senior engineers blindly approving junior work without discussing why a change was made. But what actually works? Context-first reviews. This means the reviewer genuinely reads the ticket before looking at the code diff. Revolutionary, right? It means explicitly defining the scope, stating what is intentionally not being changed, and applying risk-weighted depth to your reviews.
Okay, section 3, the hidden breaking change.
Let's anchor this with a real-world case study. Picture this. Engineers submit what looks like a perfectly clean, well-tested, 40-line pull request for a new discount calculation method. Variables are named beautifully. Tests are totally green. By all standard visual metrics, this code is 100% ready to merge.
But here comes the catastrophic miss. The reviewer totally missed that this tiny 40-line change silently overrode a crucial rounding behavior tied to specific market tax regulations. How does that even happen? Well, no test covered that specific compliance rule. The original intent for that rounding behavior was buried in some dusty Confluence document that, let's be real, absolutely nobody was ever going to read. The fix for this disaster wasn't writing better code. It was fixing the review process. They needed to add a downstream impact section to their PRs, flag financial logic for mandatory senior review, and link to architectural decision records before approval. You have to bake institutional memory right into the process.
So how do we build that? Let's look at section 4, 4 steps to better reviews.
Here is the 4-step framework you need to transform code review into a literal defense mechanism for your architecture. Because just telling developers to look closer doesn't work. You need structure. We're talking 1. Tiered requirements. 2. Custom checklists. 3. Explicit knowledge transfer. And 4. Cultural enforcement. Let's break these down.
First up, triage is absolutely essential. Not every change needs a fine-tooth comb. A Tier 1, low-risk UI copy edit, that should take 10 to 15 minutes asynchronously. But a Tier 3, high-risk database migration or an auth change, that requires a mandatory senior review, a live discussion, and taking a solid 1 to 2 hours. If every single review is taking your team the exact same amount of time, you are either way over-reviewing the easy stuff or dangerously under-reviewing the critical stuff.
Step 2 is checklists. But actually, scratch that, generic checklists. Throw them away. We need to build checklists directly from your team's actual incident history and downstream risks. If 3 of your last 5 system outages were caused by uncaught null references and async handlers, guess what? That exact scenario goes on your mandatory checklist. You have to tailor the defense directly to the historical weaknesses of your specific system, and definitely flag that financial logic for a mandatory senior review.
For steps 3 and 4, it is all about culture. This relies on the plain language test. If a reviewer cannot explain the change in plain language, the review is incomplete, period. If they lack domain knowledge, they have to escalate it or block the pull request until knowledge transfer actually happens. And culturally, this can't just be lip service. Reviews have to be treated as a core engineering responsibility. Senior engineers need to model this, and, crucially, CTOs listen up. You must actually fund the time for this to occur. A process without culture is just documentation that nobody reads.
Let's see proof of this in action in Section 5, Redundancy over Correctness.
Here is a textbook example of doing it right during a massive job queue refactor. Instead of just submitting the code diff and waiting around, the back-end engineer proactively baked institutional memory right into the review request. She recorded a quick 5-minute Loom video walkthrough of the before and after architecture. She intentionally tagged 2 engineers who hadn't touched the module in 18 months. And she even included a specific gotcha section detailing 3 non-obvious edge cases the original code handled.
And the result of that proactive, context-heavy approach? The team caught 2 critical bugs before the merge even happened. But just as importantly, they simultaneously cross-trained 2 new engineers who could now fully own that module. That is exactly how you build redundancy into the team, not just correctness into the code.
Finally, let's wrap this up in Section 6, Bottom Line for Leaders.
This is the harsh reality you just have to accept. Your code review process is a direct input to your delivery speed and your system reliability. Because weak reviews compound. Think about it. When you let a bad merge slip through because someone was just rushing to clear their queue, you make the code base slightly more confusing. And that practically guarantees the next review will be even harder to do correctly. It's a vicious cycle.
So if you are scaling fast, you need to ask your team some really tough diagnostic questions right now to find out where your processes are silently draining your velocity. Are your reviews a bottleneck holding up deployments, or are they a liability, letting production incidents slip through? How long is code just sitting there, waiting to be looked at? Look closely at your production incidents. How many of them were rubber-stamped with a quick approval?
Which brings us to the crucial point, and I want you to really think about this regarding your own team today. Can any 2 engineers on your team explain the architectural boundaries of your core modules? If you do not have a clean, confident answer to this, your review process needs work, not just your code. Are you building institutional memory, or are you just merging pull requests?